45. So this two is not in sync. 2 seconds gap. Hmm, I think now it's not okay still. It's okay now. You are given an array of length n and must perform the following operation until the length of a becomes 1. Consider a positive integer k which is less than size of a such that a upon k is an integer. Split a into k subsequences such that each element of a belongs to exactly one subsequence. The length of every subsequence is equal. Split a into such that a k. Okay. Uh, Length of into k such that after this replace a is equal to average of s1, average of s2, average of sk, average of s is equal to the array for okay. Let us read whether there exists a sequence of such that after all operations a is equal to x. So only one element should remain. Is that true? So basically you have to select some subsequences and replace subsequences with their average. And since mod of s is same for all si to sk, we have some of the numbers should be same in the subsequence. Okay, I mean not same, like only thing that matters is this, because this will be same due to this constraint. We want a is equal to x. So at last this there should be only one element remaining, and that should be equal to x. So before that we can, if we have more than one element, then we have to replace all of them with okay. So if there are at the penultimate step, like if there are three elements or four elements, then we can split. Seven and 11. So sum of the all elements should be equal to multiple, like Is this sum divisible by 9? 9 plus 1 is 10. 10 plus 10, 10 plus 14, 24. 24 plus 12, 36. And 36 and 18 is divisible by 9. So we have, okay. So if the sum of numbers is divisible by x, then the answer is yes, else the answer is no. I do not have proof. Wrong answer on p-test 2. Is this the cells in a labyrinth and cell each n I kilometers away from the exit. Okay, exit as I guess. So exit as the last cell. Okay, particle cell. Note also that this cell is connected to the exit but is not accessible from any other cell in any way. Cell in this cell there is initially exactly one person stuck in it. You want to help everyone get as close to it as possible. Installing a teleporter in cell. It also a person that cell to another cell AI. The owner caught you and some use later. Everyone must use the telephone exactly K time. No teleporter in any cell can lead to the same cell it is in. Okay. Must find a teleporter can find that minimize the sum of distance of all individuals from the exit after using the K times while still satisfying the restriction of the. Okay. So this is K. 20 is N and K numbers also value K. This is K. So I guess we can do something like this. um, like if this is last cell exit, then we can place, we can use teleporter n, then n minus 1 up to so, like if there are k teleporters we have to use, sorry, if we have to teleport k times, then we can follow that for all these. So this should be up to n minus, so how many are there, so this is x suppose, then I want n minus x r minus l plus 1, so this plus 1 should be equal to k minus 1. Okay, so this cancel out and it remains that x should be equal to k minus 2. Okay, so what I'm saying is, like this is 1. Okay, this is first cell, this is second cell, and so on. This is nth cell, we have exit here. So if I place first here, if I place first here teleporter, then second teleporter here, then k minus 1 teleporter something here, n minus k minus, what was the x, k minus 2, so this is plus 2. Okay, and this should be equal to n minus k plus 2, sorry, n minus k plus 1. Okay, this should be equal to n minus k plus 1, all of it, and they need to, they have to use k times. So if I go here, then it will take me here, so all of them will end up at exit after k teleports. And what about them? This will use only k minus 1 steps. This will only this will be using only 1 and 2. So all of them must use. So we can write here 1. Okay. So 1 will go here. This is n minus 1 itself. Okay. This is n minus 1 itself. So if k is equal to 1, does all AI have to be unique? I is not equal to AI. Okay, A has to be between 1 and n. So we can do something like if k is 1, then directly transport to end. Okay, if k is 2, then first transport here n minus 1, then go here. If k is 3, then first go to the end, then come here, then go back to end. So if k is equal to 1, my answer is okay. This person cannot teleport to itself, so it has to teleport somewhere else. So the answer is always 1, at least 1. So this guy will always be n minus 1. Hmm. And what about else? This is n minus 1. Okay. And we can place n here. And everywhere we can place n minus 1. Okay. So what will happen? I will go to here. Then I will go to here. Go to here. They will have to use k minus 1 times exactly. I guess this is the best possible configuration that you go to n. So everywhere go to last and this guy goes to n minus 1. And whatever happens we will see. Like if k is even, then I will go to last place, then I will go to here. So the distance will be 1 for all. But if I go to here and then it goes there, then the distance will be 0. That's true for rest of them. I guess this should work. If k is odd, then C out n. Okay, you directly go to the end place. Then for the last guy, C out n minus 1. Else else what? If k is even, then if k is even, then you go here. It goes there, comes back, and it goes there. Sorry. First you go here. So 1 unit is here. Then you go here. When you come back, you go here. So then you go here. Then you come back. And you go here. So this is even, and this is odd, and this is odd. So this makes everything even. So you go to n minus 1. So C out n minus 1. And since we cannot go to itself, then you see your n, then you see out n minus 1. Is this correct? Two one two three two. Your you and your team have worked tirelessly until you have sequence A1, A2, A2n plus of positive integers satisfying these properties. Are pairwise distinct. Okay, A1 is equal to 80. However, the people you work with wanted to publish this sequence first. They deleted one number from this. suffer the rest. And say and want to find a way to using many possible, you cannot put any of them. It can be proven under at least one sequence A exists. Okay. Only one number is missing. Okay. Suppose if A1 missing, if A1 is missing, then how can we check it? Pairwise distinct. So the missing number should not be among them. Like first of all, the sequence here should satisfy the conditions. So these are the conditions. Okay. And it should be possible to obtain B after deleting one element from A and supplying the remaining elements. So all of the numbers are fixed. Since we have to like we after deleting any one element, the sequence B and A should be same. That is what meant by this condition, supplying the remaining elements. So in order to form A, we have to use all the elements from B, and we can select an extra element of our choice. And the only condition which prevents us is like the only condition which we have to satisfy is that that number should not be among them, and it should satisfy this condition. Okay, so first of all we can check the sum, this sum. After checking this sum, if these two are not equal, like sorry, if this element, first we will find b1 minus b2 plus b3 minus up to b2n, like alternative sum, like in this fashion. And after, if that element is not among them, then we can output that sequence, like that alternating sum should be equal to the first one. But if they are equal, then what can we do? Then we have to select any of the remaining things as the first element. So we can perform this alternating sum. If I sort it, then this alternating sum of this sequence will always be less than equal to 0. Not less than equal to 0, it will be strictly less than 0. Why? Why? Because this element is greater than this, like b of 2n is greater than this, and so on. So this will be exactly less than 0. strictly less than 0. This will be strictly less than 0. What does it mean? So this will be strictly less than 0, and if that number is not in this, then we can output it directly. If it is present, then suppose we have sorted B. So B1 is now B1 is greater less than B2, and they are pairwise, they are distinct. So B1 is less than B2, B3. We can create an ordering B of 2n. Okay, and this will be B of 2n minus 1. 2n minus 1. Okay, B of 2n minus 1. So if that, like, lesser defined D is equal to alternating sum of, like this, B1 minus B2 plus B3, sorry, this will be B3 minus B4, and so on. Okay, so this is less than 0, this is less than 0, and this last will be less than 0. Okay, and now, so the D is less than 0, and now let us look at sequence B1, B2, and this is B of 2n minus 1. Okay, so if D is somewhere, like if D is equal to some Bi, then we have to think. If it's not, then we can simply output D and then B1 up to Bn, B2n. So this is A, not equal, not equal case. But if they're equal, then then we have to check for some valid Bi, which can, sorry, which is eligible for, which is eligible which is eligible to be A1. Okay, which is eligible to be A1, which is eligible to be A1. So how to decide, like if I want to check whether Vi is eligible to be A1, how can you check? So Bi should be equal to B1 minus B2, so on, plus B of 2n minus 1 minus b of 2n. But now there is one less element. So we have to insert some element x. All elements are positive. So this is positive. These are positive, then this number will be negative. But I want a1 to be positive. Strange. So in order for a to be positive, vi is given 10 to the power 9. So what if I decide to make b of n as the first element, like b of 2n? Then this is all good. Okay, and this is b of 2n minus 1, and this should be positive. So and here I keep plus x minus b of 2n minus 1. Okay, so this should not be less than 10 to the power minus 40. This should be at least greater than, and this is 10 to the power 9, and if a x, so x should be equal to b of 2n minus 10 to the power minus 14 and plus 10 to the power 9. So this is 10 to the power 9 2 times minus 10 to the power minus 14. Okay, so x should be greater than equal to 1. That means this value should be greater than equal to 1. We can make like this b2 minus b1. Okay, and so on plus x. So this should be 10 to the power 14. 10 to the power. So this will be is greater than equal to 10 to the power 14. Is that true? But this is always greater than equal to 1. It is true. So can I select x is equal to b of 2n minus that rest alternating sum, okay, rest alternating sum, and then so x is equal to b of 2n minus plus b of 2n minus 1. What about uniqueness? Can we make x, we are making this sequence, okay, with b minus 2n minus 1. If I do this, so this is d, so x is equal to b of 2n. Okay, if I make this negative, then x will be always greater than b of 2n. That's true. And so x will be unique. Is this true? So what is my goal? My goal is to calculate the alternating sum, which is RAS. So my goal is to make x is equal to, sorry, my goal is to create a sequence like this. X, then b1, then b2, sorry, my goal is to create b of 2n, b1, so on till b x, b of 2n minus 1. Okay, here, so this will satisfy condition b of 2n is equal to all of this, b of 1 minus b of 2, so on till x minus b of 2n minus 1. So in order to satisfy this, what should be x? X should be b of 2n minus, this is alternating sum, rest alternating sum. I call this rest alternating sum, and this is plus b of 2n minus 1. Now what is the thing, like this is negative. Why this is negative? Because of the arrangement I have picked. So this is less than 0 and this is greater than 0. So if I add, so this negative makes positive. So if I add something positive to this b of 2n, then this should work. Okay, let us go. uh, what is this in this is explanation. Okay, so n and then I read two n integers. B of 2 into n comma 0, I of 2 into n. First I sort, and then I I calculate the alternating sum. um, how long did I go? So 2 into n minus 2, but that was in one indexing, so this is with 3. This will, if I and 1, then you subtract b of I, else you add b of I. Nice. So now what should be the sequence? Sequence will be c out b of 2 times n, okay, and then c out 2 times of n minus 3. This would equal to c out b of I, then c out x. What is x? Now x is equal to b of 2 times of n minus resultant sum plus b of 2 times of n minus 1. Okay, okay, this is zero waste indexing. So this will be minus 1, this will be minus 1, and this will be minus 2, and then I see out x, then I see out b of 2 to the power n minus 2 to the power of 2n minus 2. This should be the answer. I just have to check whether it is distinct or not. Okay, 9, 11, 2. These are all distinct. Okay, and 11 minus 2 is 9. That's correct. I guess this should work. Let us try submitting. That's correct.